So the question is talking about a separately excited DC motor is fed from 230 volts 50 Hz supply via a single phase half control bridge rectifier. So separately excited DC motor is given to whom? Single phase half control bridge rectifier. So our dealing is about half control bridge rectifier, which is single phase. So armature parameters are, they give inductance value, they give resistance value, they give motor voltage constant, and they give field resistance. So the field current is also controlled by what is this? Sorry, semi-conductor converter. Okay, so it's controlled by semi-converter and is set to the maximum possible value. So the load torque is given at 800 rpm. The inductance of the armature and field currents are sufficient enough to make the armature and field current continuous and ripple free. So means whatever the values we are given, they are enough. That's what the statement says. Now what we should find? Compute. So what we should find? Compute field current and firing angle. Okay, so now what is the given data from the beginning? They gave 230 volts 50 Hz separately excited DC motor to a single phase half control bridge rectifier. Okay, so it is 230 volts separately excited one. So I will say it as root 2 times 230. Frequency is set as 50. Then later they gave inductance value as 0.06. Then armature resistance is 0.3. Constant value Ka is 0.9. Field resistance is given as 104. Load torque is given as 50. And then speed. So speed is given as 800 rpm. Now what we should find? We should find first field current, then second one firing angle. So this is the given data and this is the question we are asked for. Now we know that E is equals to IR, like V is equals to IR. Here we are referring it as E. Okay, so E is equals to IR, I is equals to E by R, right? So I will say field current is equals to field voltage by field resistance. So already field resistance is given. So field resistance is given as how much? Field resistance is 104. So field resistance is given as 104. And the question already said that it is a half control bridge rectifier. So for single phase half controlled bridge rectifier, EF is equals to EM by pi into 1 plus cos alpha. Here they said maximum field voltage and current are sufficient, right? So as they said that statement and maximum field voltage and the current are achieved, here it means there is no alpha. Alpha is equals to 0, said in statement. Okay, as they said in the above statement that condition is maximum field voltage and current is achieved, alpha will be 0. Therefore EF is equals to EM by pi into 1 plus cos 0. Cos 0 is how much? 1. So EM by pi into 1 plus 1. 1 plus 1 is 2. So this is equals to 2 EM by pi. But what is EM? Initially we said EM is equals to root 2 times 230 as it is separately excited to a single phase half control rectifier. So I will say root 2 times 230 divided by pi. So now you are supposed to use the calculator. If you use the calculator, you will get 207.07. our intention is to find IF. So IF is EF by RF. EF we got is 207.07. RF they gave is 104. RF is given, EF we found out. So now if you divide, you will get 1.99 amp. Therefore IF is equals to 1.99 amp. So first question is done. They were asking field current. To know field current, the formula we know is IF is equals to EF by RF. RF is given but EF is not given. But they said it is a single phase half wave control bridge rectifier. We know the formula for that. But alpha is 0 according to the statement they gave. So we did EM by pi into 1 plus cos 0. Finally we got EF. Once we got EF, we substituted in IF formula and we got IF. So this is the first question asked, the field current. So we are done. Next is what? Next they were asking firing angle, right? So second question is firing angle of the converter in the armature circuit. So they want, so second one, to find firing angle, right? So to find firing angle, already the equation said that it is a single phase half wave control rectifier. So EA is equals to EM by pi into 1 plus cos alpha. I am finding on armature because the question is about finding armature at armature. Like finding firing angle at armature. Okay. Here for the firing angle, we used field. This is the field side calculation. The first bit is about the field side calculation. So we are doing on the armature side. So EA is equals to EM by pi into 1 plus cos alpha. Okay. But EA is equals to, means armature side voltage is EB plus IA RA. Already they said RA is equals to 0.3. IA we are not aware and EB also we are not aware. So it means we should find EB and IA. So EB is given as Ka omega IF because they give constant value. Ka omega IF. Okay. So Ka is given how much? So Ka is given as 0.9. Okay. So the voltage constant, the motor voltage constant is given as 0.9. Then omega. Omega we are not aware of omega. Usually how do I say it? We have N is equals to omega into 60 by 2 pi. Now we want omega. So omega is equals to 2 pi times N by 60. So by this I am using. So now omega I will write it as 2 pi times N by 60. IF, field current, right? So field current, how much we got? We got IF as 1.99. So we can use it as 1.99. N is the speed. They gave it as N is equals to how much? N as 800 RPM. So as N is 800 RPM, we can write it as 0.9 times 1.99 times 2 pi times 800 divided by 60. By using the calculator, you will get 150.04 volts. Similarly, we should find IA. IA can be written as load torque by KAIF. Why are we using these formulas? Because voltage constant is given. So in the given data, voltage constant is given, means we are supposed to use these formulas. Actually, load torque is equals to IAIF into KA. I want IA, so I wrote it as TL by KAIF. Okay. So load torque is given how much? Load torque is given as 50. So as the load torque is 50, already Ka we know it is 0.9, If we got it as 1.99. So if you do this calculation, you will get 27.92 amps. So finally we got Ia and Eb. As we know, Ia and Eb, Ra is already given as 0.3. We are just directly calculating Ea. Ea is equals to Eb plus Ia Ra. Eb is given is calculated as 150.04 plus Ia we got it as 27.92 into Ra we got it as 0.3. When you do this calculation, you will get 158.42. Okay, so once we got this, we are supposed to substitute that Ea in this equation. So let me name this as 1, let me name this as 2, substitute 2 in 1. Okay, now Ea is how much? 158.42 Em by pi into 1 plus cos alpha. But what is Em? Em is given as root 2 times 230 by pi into 1 plus cos alpha. Okay, so now what can we do? So we can send that into left side. So 158.42, pi is in denominator, it will come to the numerator. Root 2 times 230 is in numerator, it will come to the denominator as 1 plus cos alpha. So I want is alpha, so I am bringing this side and this side. I am changing right to left, left to right. So 1 plus cos alpha is equals to pi times 158.42 by root 2 times 230. I want is cos alpha. So cos alpha is equals to pi into 158, you are going to get 497.43. Root 2 times 230, you are going to get 325.22. So this is the one I am sending this side as minus 1. So if I divide these two, I am going to get it as 1.52 minus 1, which is 0.52. Therefore alpha is equals to cos inverse of 0.52. Use your calculator to find the answer. It will give you alpha as 58 degrees. So finally we got our alpha. So here the main point is you need to find Ea is equals to Em by 1 plus cos alpha, so that you can find alpha. But for that you need to know your Ea. Ea is Eb plus Ia Ra. Ra is given, so to find Eb we wrote this formula. To find Ia we wrote this formula. Finally, once we got Eb and Ia, we substituted in Ea and we found out Ea. Ea is substituted back into the main equation. Em is given as root 2 by 230 in the given data. So now, by sending unnecessary things, exchanging them to the necessary side, we got cos alpha. So finally alpha is equals to cos inverse of that, and we got alpha as 58 degrees. So finally we got our alpha as the second one and If as our first one. If is 1.99, alpha is 58 degrees. That's it.